is a wave? Well, my dear children, a wave is a vibration or disturbance in space through a medium like air, water, or the ground. A perfect example of a wave is sound waves, as demonstrated by my buddy Eric. That's sound. So there are two types of waves, am I right? One of which is the transverse, in which a fixed point moves perpendicular with the wave motion, so it goes up and down. The amplitude is the distance from the top from equilibrium to the top, and the trough is from equilibrium, or it's the bottom point, so it's the bottom. And then the crest is the top, so the distance between the crest and the crest is the wavelength. As these spicy boys will show, sound is a transverse wave.
The second type of wave is called a longitudinal wave, which is a wave that has a fixed point and will move parallel with wave motion. If you want to see a good example of a longitudinal wave, take a ruler, put a coin on one end of the ruler, cause a vibration on the other end, the wave will go through the ruler, knocking off the coin.
Now that we know the two basic types of waves, how about we talk about some principles? Now the first one is the Doppler effect, based on observed frequency. And it comes when there's a source, and the source is moving in relation to the observer. When the source comes closer to the observer, the frequency is really high. And when it moves away from the observer, it comes very slow, as shown. Since the speed of a wave is something you need to find, you can find that by multiplying the wavelength in meters by the frequency in cycles per second. And since cycles per second isn't a standard unit of measurement, you'll find that in meters per second. It is now time to conclude our physics journey through waves and sound. And the speed of sound is our topic. The speed of sound is based on particles' movement through a medium. So if you have a gas, it moves pretty slow. The particles are like all over the place, not next to each other at all. If you have a liquid, they would move a little faster if they're closer. We would show you through a liquid, but then you wouldn't even see any of it because it would die. And if there was a solid, the particles are really close together. The speed is very fast. It's like fast. And the equation for the speed of sound in air, which we normally use, depends on temperature. Where the higher the temperature in Celsius, the higher the speed of sound. It is given by 331 meters per second times the square root of the temperature over 273 K. And T is the absolute temperature given in Kelvin. And that determines the speed of sound. Thank you for watching!
The second type of wave is called a longitudinal wave, which... Fuck.